Welcome to the Screencast-O-Matic presentation of 9.5 and 9.6, the areas of circles and the areas of irregular figures. We just have one piece of vocabulary today, and that is learning what a composite figure is. And a composite figure is made up of simple geometric shapes such as triangles and rectangles. Now, a good example of a composite figure is some stuff that you guys were doing on your greenhouse projects. And let's look at maybe something that looks like this. I think one of you had a base that looked like that. And you can make that into a composite figure. And there we have a rectangle and a triangle. So we're going to get to that in just a second, but let's talk about the areas of a circle first. Okay, we have a slogan for the area of a circle. So let's draw a circle here and think about this. Here's our area, here's our circle with our center point. And the area is all of this material that's inside the circle. And our slogan for the area of a circle is pi aren't squared, pi are round. And then we can put the formula here. The area of a circle is equal to pi times the radius squared. So I'm going to put pi r squared, and r is the radius. Okay, so pi r squared, get it? Pi r squared, get it? Pi r squared, pi r round. Okay, so let's work a couple of problems with the area of a circle. So in our first problem, a circle has a radius of 6.5 inches. What is its area? First thing I want you to do, always, is write down the formula. So I'm going to write down A is equal to pi r squared. And now we're going to substitute, and in our problem, we're given that the radius is 6.5 inches. So A is equal to pi times, and I'm going to put it in parentheses, 6.5 squared. All right, now we take out our calculators. Actually, I'm going to substitute for pi first. 3.14 is what we're going to use for pi times 6.5 squared. And when we take our calculators out, we get 132.665. And that is, it says inches. And because we have inches times inches here, the answer is in inches squared. So let's box that up. And there we have it. Okay, here's another example. A crop sprinkler can cover a circle that has a diameter of 100 meters. What is the area that this sprinkler can cover? Okay, let's draw a picture, because a picture says 1,000 words. And what are we given in this problem? we're given that the crop sprinkler has a diameter of 100 meters. So what does that mean? Let's stop and think for a minute. A diameter, of course, is twice the radius. So when the diameter is 100, the radius is 50. So that's a real important point. So we write down the formula. A is equal to pi r squared. A is equal to 3.14 times 50 squared, which is equal to 7,850. So think for a second, what are our units here? It says in the problem that we have meters, and our radius would then be in meters squared. So our answer must be in meters squared. Okay, let's go on. We're going to go on to irregular figures. And again, we said that irregular figures and composite figures are the same thing. And so let's think about it. There are a couple of different methods that we can use to calculate the area of irregular figures. And let's take the one that we had. I think it was Jad and Benjamin that had a thing that looked like this on the base of their greenhouse. And what you can do is lay this figure over a grid and just count the number of units, the number of little squares that go to make up the figure. And that may not be the best drawing, but we're not too bad here. We'll just count that as the same. Okay, so if I take my grid to be this unit and wanted to know how many square units are in each one of these composite figures, I would say 1, 2, 3, 4, 5, 6, 7, 8. And that's kind of a half, 8 and a half. 9, 10, 11, 12, 13, 14, 15, 16, 17. And there's 17 and a half. There's the other half. So 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So maybe 34, 35. Okay. So that's kind of the informal way, and then the formal way would be to split the figure into shapes that you can calculate the area of. So let's take an example. A basketball free throw area is shown in the diagram on the next page. What is the area of this part of the court? And you have this in your notes, and here we have it. So what we're asking about is this area here. So it's composed of a rectangle, and it's composed of a semicircle. So let's kind of draw this out here, and we can read the dimensions off of the diagram. So we have a rectangular area plus a semicircular area. And I can read off the diagram that this has a 6-foot outside radius. So this area here is 6 feet. And then if we add up all these little foot markers here, we get 4 plus 3 plus 1 is 8, 11, 14, 17. So that's 17 feet from behind where that basket is. So here's the basket and the basket, the place where the basket is mounting, and then 2 feet behind that. Okay, so we have a total of 17 feet here. And then once again, they said that this was a radius of 6 feet. So this is going to be 6 feet this way and 6 feet that way. So that is a total of 12 feet. So the area of our free throw section is the rectangle. Let's write down the formula. Length times the width of the rectangle plus, this is a semicircle, this is not a full circle, so it's a half of the area of the circle, which would be pi r squared. So the length is 17 feet. The width is 6 plus 6 is 12 feet. And then for that semicircle, we have 1/2 times pi times the radius squared, so that is 6 squared. So if we crunch the numbers, we get, okay, so 17 times 12 is 204 plus 1/2 pi times 6 squared is 113.4. So 204, that's a 4, plus 113.4 divided by 2 is 56.52. So you add that up for a total of, I'm going to start out here with the decimal place, 0.52, 260.52, and we look at our units. These are all in feet, so our units are in feet squared. All right, we just have a couple of minutes to go, and what I wanted to do really quickly is come back up to area of a circle and give you what happens if I have an area of a circle that is 50, and I ask you, or let's say feet squared, and I ask you for the radius. You would say 50 is equal to pi r squared, and then you would solve for r. But this is going to be something that we're going to encounter in just a little bit because we haven't gotten to how you find r from r squared. So I just wanted to give you a little taste of that, because that's the next thing that we're going to study in the future. In the meantime, I hope you all have a great week, and we'll see you next week. Take care. Bye-bye.